Let's practice a little bit more with this idea of a vertical stretch. Here in front of me, you see a graph f of x is equal to y. Let's say I want to graph 2f of x is equal to y. Now again, I'm not giving you the algebra for this, but I am giving you the graph, and each one of these comes with ordered pairs. Let's label the ordered pairs. So this ordered pair over here is negative 3, 0. This ordered pair over here is negative 2, 2. This ordered pair down here is negative 1, 0. And over here we have the ordered pair 3, 2. So when we multiply this graph by 2, well, that's what this value is over here, what that means is we're doing a vertical stretch by a factor of 2. That means we're going to keep our x values constant, and we're going to multiply each one of our y values by 2. So let's take a look at each of these ordered pairs, and let's write the results here in green. So when I multiply my y value by 2, this ordered pair negative 3, 0 is still going to be negative 3, 0, because 0 times 2 is 0. Let's put that little x right there. When I multiply the y value, which is 2 over here, by 2, this ordered pair negative 2, 2 is going to be transformed into negative 2, 4. Let's graph that ordered pair. Here's negative 2, 1, 2, 3, 4. So that point's going to be right there. When I multiply this ordered pair negative 1, 0 by, when I multiply that y value by 2, we're going to get negative 1, 0, again because 0 times 2 is 0. And then when we multiply this ordered pair 3, 2, when we multiply that y value by 2, that's going to transform us onto 3, 4. Okay, so let's graph 3, 4. 1, 2, 3, 4, and that's going to take us to right over here. So remember, and let's write the answer in green, remember what our graph should look like. We should get about the same shape, but a vertical stretch by a factor of 2, which means it's going to be twice as tall. And if you compare the green to the black, it is twice as tall as the black was.